All right, here we go. So we have, this is video C20 combinations from one set. This is part 2. So having gone through part 1, I'm hoping that you can or already have paused the video and done the question. And this question is super lame if you watch the previous video, because I I'm going to say accidentally use that as one of my examples. But if you didn't know that, you look at that and go, I got nothing. Well, let's see what we can figure out. N choose 2 is 100 choose 98. Well, let's do 100 choose 98. So on this side, we have 4,950. So what we could do is just start guessing. We don't know what N is. Let's pick a number. Let's try 50. Why not? 50. Choose 2. All right, so 50 choose 2 is 1,225. That's not big enough. I'm supposed to get this number. So let's try 75. Choose 2. All right, so it's 2,775. We're getting closer. So that means I just need to pick another number. And I am randomly just picking bigger numbers. Oh, look, we're getting closer. All right, let's go. Oh, just for fun. Whoops. I used permit. 98, choose 2. All right, 4753. We're almost there. I suspect all of you already know that it's 100. Choose 2. Right? So it's 100. Choose 2. There's your answer. Now, if you didn't, you could also have gone to 125. And you would see that your answer is too big. So then you would be able to bring yourself into a range and eventually get the answer. That's called guess and check. It's not necessarily the best way to do that, but some days, honestly, and it's summer holidays, it's a good way to do it. Okay, look at the next one. From a class of 20 girls and 14 boys, a group of 5 students act as guides. How many different selections of guides I've got can be? There are no restrictions. Okay, so I'm going to choose 5. How many kids are there altogether? Picking 34. Let's see. 34. 5. Whoops. That's good. 0. Great. Let's try that again. 34. Choose 5. And there we go. We got our answer. 278,200. Okay, so no boys are chosen. So choose 5. If there's no boys, that means I only have my 20 girls to choose from. Five. 15. 5. All right, no girls are chosen. This could have just been an awkward way to say only picking girls, picking boys. Doesn't really matter. Okay, so no girls, that means it could be 14 boys. We choose 5. 14, choose 5. Both boys and girls must be represented. I know what the answer is. I want you to think about it. So there's a way to do this using 2 sets or using cases, and that would be like 1 boy, 4 girls, 2 boys, 3 girls, and go through all the cases. That actually works. You can come back in the next section. The easiest way. No boys, no girls. And this is the opposite, at least there are some boys and girls. So it's picture time, folks. Here we go. Use that complement again. So there are 278, 256 different choices, different sets of kids we can use. Now, some of those are no boys, and that was 15504. And there's another group, and they're both subsets, but there's no intersection, right? And this is no girls. 2002. So if we take this number and get rid of these two, so the background here, the complement, some boys and some girls. 278, 56 minus 15, so that's the ones that have no boys in them. And then we're going to take away the groups that have no girls. Open. 78. Minus 2002. And that gives us the 260, 750 that we're looking for. Okay, so complement. I will color this pretty yellow, and I will put color here. That reminds you that's where that came from. All right. It says that Dave and Laura must be among the chosen. All right. So we got Dave, we got Laura, and then we need how many more students? Choose 5 altogether. There's Dave, there's Laura. That leaves us. We're going to have to choose 3. Now, there were how many kids altogether? There's 34, and we took 2 away. We took out Dave, we took out Laura because they have to be in our group. So that should be us 32. Let's try that. 32, choose 3. And there we go. So again, one more time. We picked Dave and Laura first. So there's 5 students altogether. We picked Dave, we picked Laura. So that means we have 3 more to put on our selection. And there were 34 kids, 34 students to start with. And we already picked 2. Or we already, yeah. So if there's 34, we picked 2. That's where the 32 came from. I guess you could have said that there's going to be 19 girls and 13 boys to choose from now. But it was the workout. Okay. Now, this one says Dave and Laura must not be among the chosen. You guys catch that? Look. Must be. Must not be. I'm thinking we can do that by a complement. I don't know. I think there's 2 possible answers. Let's try it both ways. Okay, so one way to think of it, we've still got to choose 5 kids, 5 students, and we can't choose Dave and Laura, so there were 34 to start with. Take away 2. That leaves me 32. Choose 5. Choose 5. And that gives me my right answer, 201, 276. But what my brain was wondering is if we did it by the complement, what if we went 278, 256? Oh, I'm already thinking this is going to be wrong. But let's try anyway. 278, 6, oopsies. 278, 6 minus 4960. Yep, that didn't work. I was thinking too much. Okay, you can't see that. So this one didn't work because I tried to do it by complement. This is all the groups that Dave and Laura are on, but there's going to be some groups that just have Dave, and some groups that just have Laura. So if we knew this one and we calculated those two, then we could subtract. But this is way simpler, so we'll just never you mind that. All right, now we're going to talk about cards. Once again, now since we did the top question with the students, a lot of these are similar. I bet you could try again and see if you can get them to work out now. I'm sure if the question sheet I'm going to give you isn't going to have the answer sitting there for you, because that just makes it too easy. Just keep playing around with the calculator until it works. That's not going to do well on a hand-in or on a test. Anyway, let's do it. 5 cards are dealt from a standard deck. How many 5-card hands can be dealt such that? Okay, so 5-card hands, cards. Like I said, most of the time that's going to be a combination. I guess not to mention the fact that this is worksheet on combinations. All right, so C5. Any 5 cards can show. How many cards are there in a deck? Exactly. Let's try that. 2, choose 5. You will notice I have an answer over there, and I have an answer here, and they don't match. Whoops. Let me try that again. There are 52 cards. We're going to choose 5. Okay. 2, 5, 9, 8, 0. Which really makes me wonder where I got that number from. So I'm going to pause this, find the question, and see where I did it from. Okay. That's just a typo. There should be a 2 in there, so we're fine. All right, let's do the next one. I am still picking 5 cards. You know what? All of these questions, I am picking 5 cards. All the way down. Okay, all the cards are red. So, how many red cards are there? 6. Let's try that. 26. Yes. 5, 7, 0. Now, all the cards are black. Well, that's exactly the same question. Really. Now, both colors are present. Are you seeing the pattern? You see the pattern from earlier? So, because this is the opposite. All are red, all are black. It's having both. So it's the complement. So there's 2 960 different cards. Or sorry, different hands. And there are 65,780 of those sets that are all black. And there are 65,780 that are red. So here in the background are ones that contain both. Oopsies. Sorry, I'm off screen. Both red and black. So if we subtract, where am I going to put this? 5. 0 minus 5. 0. Of course, lost myself. I'm not going to have that fairly. All right. So 25, 9, 0 minus 5,000 minus 65,780. That answer there. Okay. There are no hearts. Okay. Well, let's cheat and do F first. There are only hearts. How many hearts are there in deck? 13. Choose 5. 1,207. So if there's no hearts, there's 52 cards altogether, minus the 13 hearts. Or you can go, there are 13 clubs, 13 spades, and 13 diamonds. Either way, that's going to give you 39, choose 5. That's just a cool number. Okay. There are no 2s or 3s. All right. It's 2 cards to start with. Take away 4 2s, minus 4, and then take away 4 3s. So let me just write that so somebody later can see where this comes from. So 52 minus 4 minus 4. I could have subtracted 8, yes. It's 44. Choose 5. 0, 8, 6, 0. All right. Ooh. Not sure that last question is legit. Anyway, let's go to this one. They're only base cards. So my base cards are going to be my jack, my king, sorry, jack, king, queen, 3. And there's 4 different suits, so that's going to be 12. So 12, choose 3. Oops. That's not right. Let's try 12, choose 5. There we go. All right, this last one, I shouldn't have put in here. This is really doing 2 sets, but here's the way you have to do it. Got to think it through. If we have to have all 4 aces, so we got ace of spades, ace of diamonds, ace of clubs, ace of hearts. So that gets rid of 1, 2, 3, 4. So this part's going to be wrong. I already have 4 cards, already picked. So now I need 1 more card. Okay, so I'm not choosing 5 cards. I just got to choose that 1 leftover card because I already have these ones. And if these ones are already gone, they're already picked, they're in my hand. How many cards are left in deck? So you start with, take away 4. That's where your answer comes from. Okay, that was a little bit of a tricky one. You could think of it in terms of ace of spades, diamonds, hearts, clubs. There's one, there's one, there's one, there's one. And there's 48. So this is one where the fundamental counting principle will work, but that kind of only worked because these were all. So I'm now regretting showing you that, but that's another way to do it. Fundamental counting principle doesn't always work with combinations. Right, end of the video. Have a spectacular day, and I hope you are really rocking this stuff. It's pretty cool. You gotta practice.